Hello, and welcome to this introduction video about DiSSCover, DiSSCo's portal for making annotations on digital specimens inside the DiSSCo digital infrastructure. My name is Tom Dijkema. I work as a software developer at Naturalis Biodiversity Center in the Netherlands. And in this video, I will take you on a tour showing the basic features DiSSCover provides. You can also give us a try in our live environment at discover.dissco.eu or follow the link in the description. The application itself provides a similar tour to what we show in this video. About DiSSCover itself. So DiSSCover is an online web application that can be accessed from every compatible web browser. The layout is quite simple, but it includes some complex functionalities, like the main feature of DiSSCover, making annotations. DiSSCover allows users to annotate digital specimens, either manually or using computer systems we call machine annotation services. And this aligns with the core mission of DiSSCo, to improve the quality of natural history data, in which annotations are a crucial part of achieving this mission. Besides annotations, DiSSCover provides detailed landing pages for digital specimens and associated media, and enables you to search and explore through this natural history data catalog. We kick off this introduction video here on the homepage, where as you can see, there are multiple options and routes to take. From using the navigation bar on the top, the different categories on the left, or the plain search bar on the right, each of these options allows you to browse through the application and discover the digital objects within. The 9 different categories on the left are placed pretty prominent and are in fact called topic disciplines. Each discipline represents a certain spectrum of the digital objects catalog. For example, paleontology for fossils, botany for plants, and astrogeology for meteorites. These categories are bundled under the umbrella of natural origin. Next to this, we also support human-made archive material and objects that are truly unclassified. We also provide a generic search bar, in which you can search for digital specimens with a free text query. This query will try to match any of the terms that are related to a digital specimen, making it very broad. And hidden beneath is the option to execute some advanced searches. For example, you can directly provide a DOI of a digital specimen, the DOI being the unique and resolvable identifier. This option is also available for the physical identifier. And we also provide a direct search based upon the institution or collection facility. You can also combine options. Let's combine the presented options to search for some digital specimens. I will select the zoology topic discipline and query for spirobranchus, this being the Christmas worm. Click on search and this will take us to the search page, displaying the search results of our query and our filter in this table. This page, which we call the search page, allows for even more specific search queries and displays the results in the table. If specified, it is directly affected by the search conditions, like we did just now on the homepage. So the records in the table obey to the filters we set, like for example the zoology and our query. And every record in the table represents a digital specimen. When we click on one, it actually extends the amount of information provided about it. We call this the Digital Specimen ID card. It holds the basic information needed to identify the digital specimen and also indicates if it has associated media or not. You can easily browse through these by selecting different records from the table. So we do find some Christmas worms, but possibly with different data, associated media, and for example different identifiers.
The search table can hold up to 400 pages of records, and that is why we provide a bunch more filters to further refine the search results, up to a fine level of detail. For example, we can also filter on country. Or if we only want to see specimens with associated media, we set it to true. And as you can see, sometimes we put in so many filters it doesn't return anything. So remove one and it will return what's left. The most powerful and complicated of them all is the taxonomy filter. And the taxonomy filter allows you to search through the taxonomic tree of all the records in DiSSCover, activating different taxonomic levels as filters. And we're also able to search directly on species level. For example, if we enter our name of the Christmas worm, so spire of branches, it gives a few different options of species we can apply as filters. Let's pick spire branches giganteus. As you can see, it automatically fills in the holes in the taxonomic tree. So a path from the kingdom level towards the species level is crafted and becomes visible. Next to the default filters, DiSSCover also provides quality completeness indicators, starting with one called MIDS, or minimum information about a digital specimen. The higher the MIDS level, the more complete the digital specimen is, and filtering on higher MIDS levels will actually return more complete digital specimens. It is important to note that specimens with lower MIDS levels are not bad per se, but they are missing some key values which MIDS checks for and should be present in the digital specimen. Another neat feature present on the search page is the ability to compare digital specimens with each other. This can be very useful to detect the smaller differences. By triggering the compare mode, we can select up to 10 records from the table. Then, when we click on compare, it will take us to a new page where the comparison is shown. Per digital specimen in a vertical row is shown which details are there. You can also remove or add any digital specimens during comparison. So for example, we can remove the last one, or add an additional one from the table. Moving on, we want to have a look at all the details of a digital specimen. In this scenario, we return to the search page, select a record from the table, so the ID card becomes visible, and click on this button, See Full Details. This takes us to the Digital Specimen detail page. This page provides all the information stored within DiSSCo about the digital specimen. On the left, we've got the familiar ID card, and on the top, the possibility to go to a different version of the specimen. The overview tries to sum up all of the most important details, including a citation. The rest of the information is divided into different tabs. We've got the Digital Media tab, including all of the attached associated digital media, like photos, videos and audio. Events, for collection or other types of events, holding location information. Identifications, holding all of the identifications and related taxonomy. And entity relationships, for all links to external systems. And possibly there can be even more. For example, assertions, if those are present. Each tab contains a table-like structure containing all the dedicated information. And the entity relationships, like you can see, also contains an interactive graph, in which the relations to the external systems, like ROR and FDO, for example, are displayed. And clicking on the dot actually takes us to the resource, for example the ROR page. This might be a lot to take in. Luckily, DiSSCover also maintains an internal tour functionality, in which you can take the time to read and learn about the different sections and functionalities on this page. And now for the main event. Let's look at how annotations work. Right off the bat, we're going to look at a manual annotation, which is an annotation made by a user using a manual action. Later on, we will look at the machine annotation services. Annotations are hidden by default, and we need to trigger the annotation mode to be able to see them. By clicking on this button, and doing so, shows us this side panel. Here all the annotations for this particular digital specimen are listed. You can sort by date, but also filter by motivation. The motivation of an annotation states the reason for creating it. You can add, modify or delete values, and comment or assess data. With the annotation mode active, the base digital specimen page also changes, as previous static elements on the page become interactive. But first, let's dive into what annotations are all about. With annotations, we can fill in the holes in a digital specimen and make it more complete. Update existing values if there are errors, or simply spark discussion about certain traits with assessments and comments. DiSSCover allows for annotations on all the different levels of a digital specimen. This is a bit complicated, as levels can vary very much from each other. But in a basic sense, this comes down to classes and terms. A term is an individual property of a digital specimen, describing a trait, for example the scientific name, the collection code, or a locality. A class is a collection of terms. So for example, there exists a location class, which holds terms about the location of the digital specimen, like locality. Alternatively, classes can also hold other classes, as the location class also holds a georeference class. As you can imagine, there are loads of different possibilities in targeting different classes or terms on different levels of a digital specimen. Not even speaking about classes within lists or all the different data types of terms. Luckily, you as a user don't have to think about this logic, as DiSSCover offers a wizard to guide you through this process of annotating on a certain level. Let's try that out. First, make sure that you are logged into your DiSSCo account and you have an ORCID linked to your profile. Otherwise, you will not be able to annotate. You can sign up or log in on the top right corner, and also navigate to your profile to link your ORCID. Let's boot the annotation wizard to make a new annotation. In total, there are 4 steps to complete to make your annotation. Step 1 lets you define the annotation target, and this can either be a class or a term. The wizard already provides some benchmark classes, which are often used and set the target with just one click. You can also use the advanced selection to search for a specific class or a specific term using these drop-downs. These will allow you to search through the whole digital specimen schema. We will add a new identification, so we will use the identification benchmark class. In the second step, you can select the instance of the target to be annotated. This layout heavily depends on if a value exists, if the target is present in a list, or if a parent is missing, and might thus be different for every target you want to annotate. In this case, we can add a new instance of identification, or edit an existing one. Let's add a new one, so we'll select Add Instance of Identifications. After selecting it, click on Next Step. The third step generates a form based upon the annotation target and the instance you have selected. And this form allows you to define values. As we selected a class and are adding a new instance of identification, we will be able to fill in all the classes and terms inside of the identification class. For example, we can add a date on which identification was made. If we want to add values for taxonomy, we can add a new taxon identification class that's within this identification. And we can define something like the scientific name. You may have noticed that some classes and terms were pre-filled. Our aim is to assist you as much as possible in the annotation process. So using pre-filled default values, we will try to relieve you from work. Use this form to create the value you want to create for the digital specimen. The final and fourth step summarizes the previous three. Your job is to review the annotation you're going to make, to define target, motivation, and of course the values. All values that are new to the digital specimen or have been modified are marked with blue. Once satisfied, we save the annotation. It loads and redirects us to the overview, adding the new annotation to it. The annotation record holds the values which we just annotated, indicating we made the annotation, the motivation, and the target. As the publisher of this annotation, I am able to edit it. This will reopen the wizard and only display step 3 and 4, and those are relevant. You can change the value, review it, and save it. It will update this record in the table, or no view. I can also delete the annotation, if I wanted to. In fact, it will not be entirely deleted, but rather tombstoned. Apart from defining a target in the annotation wizard, it is also possible to target using the interactive elements on the Digital Specimen page. For example, I can select the specimen name from the ID card, which sets the target and filters the annotations in the annotation overview on this term. If I would like to add a new annotation, it also skips the first two steps accordingly, as we define a target and an instance. And since an element on the Digital Specimen page always makes use of a specific instance, we can continue from here or go back and change our target or instance at any moment. To conclude, there are a bunch of different routes you can take to annotate, each one a bit different from the other. But the annotation wizard will help you as you go and catch all inconsistencies for you, aiming for the most optimal annotation process possible. Next to manual annotation, DiSSCover provides you the ability to run machine annotation services, MAS in short. A machine annotation service is an external service, often developed by third parties, that can offer meaningful additions to the digital specimen. For example, the GWIF occurrence linker tries to find a relative occurrence for digital specimen inside GWIF and creates a linkage using an entity relationship. Machine annotation services often make use of machine learning, either to detect these linkages or many other tasks, like recognizing the information of a label that is published in one of the associated media items. Let's schedule a new MAS. This will provide a short description and a list from which you can choose one or more MASes. Yes, you can actually schedule multiple MASes at the same time. And after selecting the selected MASes will appear in the list, indicating what you're about to schedule. Finally, click on the schedule button to execute the scheduling of the MASes. After the loading process, it will return us to the MAS overview, where a MAS job record is shown as a representation of the mass we just scheduled. By the spinner, you can see that it's still loading. Each mass takes some time to finish this process, but once so, the state will change in the icon with it. Skipping on ahead a minute or two, you can see the mass has finished and the icon has turned to a green check. And if we return to the annotations overview, it is clear the mass added a new annotation with the values it found to be true. And thanks to this fully automated process, more value got added to the digital specimen without any real human labor behind the task. The power of masses, together with human verification, is one of the groundbreaking concepts within DiSSCo. Some specimens actually have associated media. You can click on them, which takes you to a new page. This digital media page provides a closer look on the associated media of a digital specimen. And it's similar to the digital specimen page, providing an ID card of the most important details of the media item and a content section with details. In the main overview, an interactive image viewer is present. Using this viewer, you can zoom in and out and freely move around an image. The viewer component also supports the IIIF standard. If there are any other media items linked to the one we're viewing, they will be displayed at the bottom, serving as an easy way to navigate between them. Next to the viewer, there are two other tabs. One which stores all the metadata in the table, and the other which holds all the entity relationships for this digital media item. The page offers the same kind of annotation functionality like the digital specimen page. Except of course, the base digital object is the digital media item, providing different classes and terms that can be annotated. The same applies to the machine annotation services. Aside from default annotations, the digital media page also allows for visual annotations to be made upon images. A visual annotation consists of a bounding box drawn upon an image, indicating a certain part of the image and attaching an annotation value to it. For example, we can draw a bounding box around this leaf. So we can indicate this leaf is part of the overall specimen. This of course being a regular leaf. But with this annotation, we can recognize the leaf as an individual part of the specimen. This way, visual annotations create additional value to the digital media objects and help understand what is being shown on the image. Machine annotation services can also be applied to digital media objects for creating visual annotations. For example, the plant organ segmentation mask uses machine learning to detect the individual organs of a plant, like leaves, flowers, stems and more. Let's run it to see what happens. We open the annotation side panel and the mask menu, and like before we select the plant organ segmentation mask from the list. Finally, click on schedule. In the meantime, the mask has finished running, and as you can see, it has created a lot of bounding boxes on the image, indicating the different organs of this plant, like leaves, stems, and all the other parts you can think of. This really shows the potential of masses on digital media objects. It is so broad that it can also help to fill default metadata in digital specimen objects, for example by reading the labels. The potential is really limitless.
Thanks for watching this video about DiSSCover, presenting its purpose and core functionalities. Development is always ongoing and feedback is really appreciated, so please don't hesitate to send us your feedback. In the meantime, please also have a look at the DiSSCo website and other relevant materials found in the description below. For now, This is Tom, signing off. See ya!